So I figured I would incorporate some homework answers into today's lesson with this particular video, okay? Number one, evaluate each of the following for x equals 4, 7, 9, 13, and 2. So the sum of the x squareds would be 16, 49, 81, and 169, and 4, okay? The next setup would be the sum of x squared minus 1. Well, in this case, what they're really saying is you got to find the sum of the x squared, which we just did. I don't know why in the world my cursor's not showing up here. I apologize that it's not, but it is not. So, oh, there we go. A little click puts it there. Oh, let's go back to the sum of the x squareds. 16, 49, 81, 169, and 4. Add them all up. Bingo, 319. The next one says the sum of x squared minus 1. So I take the 319, I subtract 1. Now the next one, it's what I'm really getting at here is that you understand that in the first one, it's like a variable, the sum of x squareds. That we already figured that out, that was 319. In the second one, by parentheses, the order changes. And you have to subtract 1 from each of the x squared. So 16 becomes 15, 49, 48, 81, 80, 169, 168, 4, 3. Then you add them. And in this case, you come up with 314. Now, the next one says 2 times the sum of the x squareds minus 1. So the sum of the x squareds was 319. I multiply that by 2 to get 638, and then I subtract 1 to get 637. 2 times, now in parentheses, x squared minus 1. That's this third one up here, the middle one. That was 314, so 2 times 314 is 628. For the next one, this is just a little bit of a review type of question with a normal distribution, mean of 57.3. Standard deviation of 4. 73rd percentile. In both cases, I do second var's inverse norm. 73rd percentile is 0.73. 40th percentile is 0.4. Punch the numbers. That's what you put in. This is what your calculator will tell you, unless something very strange is going on. Next one, number 3. We've seen this a bunch. Personal computer, home research, blah, blah, blah. Average number of hours is 2 hours per day. Standard deviation is half an hour. That's 0.5 because we're talking about hours, not 30. Right? We got to keep it in the same units. We want to find the probability that the personal computer is used between 1.85, 2.75 hours. So this is the normal distribution. So it's not percentiles. Normal distribution is second var's normal CDF, lower 1.85, upper 2.75, mean 2, standard deviation 0.5. Punch the numbers out, you get 0.5511. Now, number 4, very similar type of question. I'm sure you read it over before, so I'm not going to reread it. But you're going to do second var's normal CDF, but this time it's between 127 and 135. So my lower is 127, my higher or upper is 135. The mean is 114.8, standard deviation is 13.1, and I get 0.1143. Now, what's different about letter B? What's different about letter B is they're talking about a mean systolic blood pressure, and they give you a sample size, namely 40 women. When that happens, we're talking about central limit theorem, and we're going to do second var's normal CDF, 130, and you want to be greater than that, so we always go 10 to the 99th. My mean stays the same, but my standard deviation goes to the error, which is 13.1 divided by the square root of 40. You always have to remember to divide by the square root of n. Punch that in, and you get an extremely small number, 1.08899. It says e to the negative 13. That's like 10 to the negative 13. Okay. Next one involves the pizza delivery. The mean time is 40 minutes. 6 is your standard 6 minutes standard deviation. Sample size is 50. So that automatically I start thinking, okay, got to divide by the square root of 50 when I do my standard deviation here. And we want to find confidence intervals. Confidence intervals, you always got to figure out what those 2 white pieces on the end of the graph around the green would be in that diagram we taught you. So 1 minus 0.88 is 0.12, but I have to divide that by 2 for the 2 pieces, and I get 0.06. Then I do second var's inverse norm for 0.0601. Remember, that's how we know we're doing it in the confidence interval mode here, where it's like a z-score mode. And I get 1.555. Then to find the error bound measurement, it's always 1.555 times 6 over radical 50. And that's the adjustment on the standard deviation. I get 1.319. And then I subtract it and I add it to the mean, and that gives me my confidence interval right there. We're in a bit of a rush here, but I'll go through it. Put all of these data into L1. Remember, stat edit L1, clear, enter at the top, put them all in there. Then you go to stat tests. That's across to the right side, third column. You want to choose T interval. It's choice 8. Input the data. Okay, when you start inputting that data, choose L1, frequency 1. For sea level or confidence level, you put in 0.98. When you do that, you will get this answer right there, 4.3195, 10.781.